This final testable skill is called the shorter truth table method of proving these argument forms to be valid or invalid. Your author breaks this up into two sections. In 9.9, he introduces it as a proof of invalidity. And then in 9.12, he notes that the same procedure can be used to prove an argument form valid. In either case, the author doesn't give you much instruction. So I feel needed for this part of the course. I don't think you'll find anything helpful in the book about exactly how to do this. So you need to pay close attention tonight and 2 Tuesdays from now. Feel free to watch the video anytime. So I'm going to look at some examples on page, let's see, 389. Now this is in 9.10, and this particular exercise bank is not presented as exercises in this procedure, but we could use any symbolic argument in the book to demonstrate this procedure. I'm going to start with number 3. For this procedure, we want to leave the argument presented in this vertical manner. Leave some space under the premises and the conclusion, because we're going to be adding truth values under our components. The first thing we want to do is assume the argument form to be invalid. It's an assumption. And what that means is it's possible for the premises to be true and the conclusion false. So we're going to supply those truth values under those symbols that define each premise and the conclusion. So you have to know how to read our symbolic language, at least to the extent that you know what kind of a statement that first premise is. That is, it's a conditional statement defined by that horseshoe. So it's that horseshoe that we're assuming to be true, because that first premise is a horseshoe. Second premise is also a horseshoe. It's defined by that one right there. And so is our conclusion. So this is the initial assumption of invalidity. We're going to see if we can supply truth values for every symbol in the argument form that justify that initial assumption. So you consider the long truth table procedure. We started by supplying truth values for the component simple statements, the uppercase letters. And the last values we assigned were for the defining symbols of the premises and the conclusion. In some sense, we're working backwards here. See, we're starting out by assigning truth values to the defining symbols and see if we can complete a row that would exist on the long truth table if this argument form is invalid. Now, after that initial assumption, you only want to proceed by supplying truth values that you're certain of. So the first premise is not a good place to begin or to continue, because there are 3 ways to make a horseshoe true. This being the antecedent, and that's the consequent. That horseshoe is true and both of them are true when the antecedent is false and the consequent is true, or when they're both false, you see. So we don't know what truth values to assign to that antecedent and that consequent. The same holds true in the second premise. It's a horseshoe we're assuming to be true. There are 3 ways to justify that. That is not a place to begin or to continue. However, in the conclusion, we're assuming that a horseshoe is false. And there's only one situation in which a horseshoe is false, and that's when the antecedent is true and the consequent is false. So those truth values will justify the assumption that the conclusion is false. So I want to circle that. That'll remind me that I'm done with the conclusion. I don't have to consider anything in the conclusion, until we're finished. Now, whenever you supply truth values for simple statements, that is uppercase letters, that occur elsewhere in the argument, you must remember to transfer those truth values before continuing. There's another occurrence of I, so I'm going to transfer that truth value T. There's an occurrence of L, so I'm going to transfer that truth value false. The reason for that is, as these can be as long as we want them to be, or as long as they can be. Those letters may occur several other places in the argument. If you forget that you've already established, for example, that L has to be false, you may assign it the opposite truth value somewhere else in the argument in an attempt to justify another symbol's truth value. So don't forget, when you establish the truth value or assign it for a letter as a component simple statement, you've got to transfer that truth value to every occurrence of that statement. Okay, so now we're looking around for some symbol whose truth value we're certain of. I see two of them. There's one in the first premise and there's one in the second premise. Now that symbol could be a letter, a simple statement, or it could be a connected, or it could be the curl operator. At any rate, why don't you just look at the first premise? See, you have to be familiar with the definitions of our symbols. When is a wedge true or false? When is a dot true or false? A horseshoe, a tribar, a curl. But there's a symbol in that first premise whose truth value I know has to be the case if I'm going to justify the assumption that that horseshoe is true. So, find it for me. Yes?
It has to be true.
Well, what does?
The first one. The consequent has to be true.
And what is the consequent? Is it J, a wedge, or K?
It should be the wedge.
It's the wedge. How does he know that wedge has to be true? Because where the antecedent of a horseshoe is true and the consequent false, that's a false horseshoe. We're trying to preserve its truth. So given that the antecedent is true, the only way to do that is to make the consequent true as well. Agreed? Okay. Well, I'm not certain of the truth values of J and K because there are three ways to justify a true wedge. True, 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 false, false, true. So that's not a place to continue. However, there is a symbol in the second premise that we're certain of, or whose truth value we're certain of, for similar reasons. Find it. Again, go.
It has the dot has to be false.
The dot has to be false. Why? Because we're trying to preserve a true horseshoe. The consequent is known to be false. If the antecedent were true, that would make a false horseshoe. You with me? So the antecedent, which is the dot, that has to be false to preserve the true horseshoe. Good? Now, I'm not certain of the truth values of either J or K there because there are three ways to make a dot false. True, false, false, true, false, false. Okay, so we don't have a move to make here. There are a couple little bumps in the road in this procedure, but there are pretty easy ways to resolve them. We want to go through as many of these as we can so we encounter, all possible little glitches or problem areas of the procedure. Now, there's a long way to do this and a short way to do this. I'm going to show you the long way. The short way requires more confidence. We could maybe pick that up later. Now, we have the same two simple statements involved, J and K. Right? So it's the truth values of J and K we're not certain of. One of them occurs in a wedge, and we're trying to make that wedge true. The other, J and K, are conjuncts of a dot, and we're trying to make that dot false. Well, we already know all possible truth-value combinations of those two statements. So we're going to make a truth table to show all possible combinations. Remember this from last week? And that's wrong. That's right. Okay, that's a true wedge, that's a true wedge, that's a true wedge, that's a false wedge. We're trying to make that wedge true. So can we eliminate any combination of truth values for J and K from consideration? Okay, any other combination will justify that true wedge, correct? Trying to make this dot false. Can we eliminate any of those combinations from consideration? That's right. Now apparently, it doesn't matter if J is true and K is false, or K is true and J is false. Either of those combinations will work, right? In fact, I'm willing to bet that there are 2 rows on this argument form's long truth table that prove it to be invalid. One on which J is true and K is false. The other on which K is true and J is false. Now, if you're not satisfied leaving those unmarked, you can pick any of those. Any of these, right? See, that'll make a true wedge, and that'll keep our horseshoe true. Got to transfer those same truth values. That'll make a false dot, and that'll keep our horseshoe true. The other combination will work. That's a true wedge. That preserves our true horseshoe. That's a false dot. So there are 2 rows on the long truth table that prove this argument form to be invalid. I'm not going to do the long truth table because it would have 16 rows on it, and I don't feel like doing that. But if you want to, if you want to verify that, you will find those 2 rows. They exist there. And one thing I want to point out at this time is that we've completed the procedure successfully. Is that good or bad for this argument form?
It's bad.
It's bad, because what we've succeeded in doing is showing that it's possible for the premises to be true and the conclusion false. That means it's invalid. So shortly, we're going to encounter some examples of this procedure where it can't be completed. A contradiction is found. So failure for the procedure. That's good for the argument form, because what we failed to do is justify the assumption that it's invalid. It's therefore valid. Okay, any questions about this particular example? We're going to do many. Any questions about this one?
So when you were in the parentheses, when you were putting the true or false on a conjunction, you were taking the J and the K together as a you were getting the true and false off of the horseshoe.
Not sure what you're asking.
Well, when you were on the horseshoe, we were on where it was true, so you went to the false on the and, right?
Yeah, we had that at some point,
Right.
and then we
But so
determined.
it had to be false.
Right.
So you got that from the truth values.
I got that?
Yes.
That's what you're asking about?
Yeah, you got.
No, I got that because
Mm-hmm. Mm-hmm.
we had a false consequent,
Wait, I understand.
right?
Mhm.
Or horseshoe has to be true.
Mhm. Right, so that has to be true under the and. That true has to go under the dot or the and, or the conjunction J and K.
Oops, I did this wrong. Sorry.
That would be false.
I did that very wrong. Sorry.
Yeah.
We have a false consequent,
Mm-hmm.
right?
Okay,
Yeah.
so it's wrong.
A false consequent. We're
Right.
trying to make our horseshoe true,
Mm-hmm.
okay?
Mhm.
So that antecedent has to be false.
Mm-hmm.
See, if we were to make it true, that would be a false horseshoe.
Right.
But that's not what you're asking about, right?
I was talking about the placement of the F going underneath the dot or and, the conjunction and. You put it there because.
Because that is the antecedent.
Right, you're using it as a whole, and then you're going back and using the table for the dot or the and to get the values or the truth or false for the J and the K. You got your mic.
I put false here
Mhm.
because the antecedent of the horseshoe has to be false. The
Right.
antecedent is the dot,
Mm-hmm.
okay?
Okay.
So then, maybe this is what you're asking, then we were trying to justify the false dot with these conjuncts.
Okay. Mm-hmm.
See, we supplied that truth value because that's what we knew. We didn't know J and K.
Right. Okay.
What a mess that is. If that didn't clear it up, we're going to do so many of these that I'm pretty sure it will be. Number 4 is very similar, almost too similar to bother with, but I will anyway. We begin by assuming the argument form to be invalid. It's an assumption. Don't know if it is or not. That means it's possible that the premises are true and the conclusion false. So again, you have to put those truth values under the correct symbol. The symbol that defines each premise and the conclusion for what it is. They're all conditional statements. After that initial assumption, that assignment, you look for symbols whose truth value you're certain of. First premise is not a good place to start. Same reason as last time. 3 ways to make a horseshoe true. Second premise is not a good place to start. Same reason. So we're starting with the conclusion again. I don't want you to think that we always start with the conclusion. You don't. You can start anywhere that you're certain of a truth value. The only way that conclusion could be false is if the antecedent is true and the consequent is false. Right? Before we do anything else, we want to transfer those truth values to other occurrences of MNP. Done. Now we continue looking for symbols whose truth value we're certain of. I see 2 of them. A similar situation to last time. One in the first premise, one in the second premise. Find one for me. Tell me what it is and why.
The first one would be underneath the and would be true, right? Correct.
In the first premise,
Mhm.
what do you say?
It would be the dot would be underneath the dot would be true, right? Correct. That's it.
Why?
Because on the horseshoe, the first two are true. So there's no false.
Vocabulary is so important for us to merely communicate. We're trying to preserve a true horseshoe whose antecedent is known to be true. If that consequent were false, that would be a false horseshoe. Therefore, the consequent, in other words, the dot, has to be true to preserve that true horseshoe. Right? Now, I'm not going to circle that. So I haven't justified that true dot. But I can do that right now. There's only one way a dot is true. What is that? Conjuncts. Both conjuncts are true, right? So we're done with that first premise. Now we want to transfer those truth values to any other occurrences of N and O. We do have N and O. Okay, we have two true disjuncts. What does that make our wedge?
True.
Please note, when you complete the assignment of truth values for every symbol in either a premise or the conclusion, especially when that completion involved transferring truth values, you have to stop and make sure that all those truth values justify the assumption of that premise or the conclusion, right? You have to make sure that a contradiction has not occurred, but a contradiction has occurred, right? Because we have a true antecedent and a false consequent. That makes a false horseshoe. This shows that this row of truth values cannot be completed. It's contradictory. Therefore, there is no such row on the long truth table. It's not there. If you want to do it, you're welcome to. There's 16 rows, I don't want to do it. But there's none there. Okay, so the procedure has been unsuccessful, not because we're not good enough, because it can't be done, and we know it can't be done. Is that good or is that bad for the argument form?
It's good.
That's good. You got to remember that. I can say it 100 times, and some students will know exactly how to do this procedure and misinterpret the results. Successful completion, bad. Impossible to complete, good. And you should understand why. Questions about that particular example? Okay, we're going to get somebody up here to show us your stuff pretty soon, because it's a pretty easy procedure. I think if we do a couple more examples, many of you, perhaps all of you, will be proficient enough to show us how it's done. But these are starting to get longer pretty fast, I noticed. Let's try number 5. See if that's all on here. Perfect. Okay, this might be a good one to practice our reading of our symbolic statements. Yes?
Could you put the truth table of the horseshoe on the board? Make it a little clearer.
Well, yeah, they're all in the book in dozens of places, but you're going to have to know them eventually. That is the truth table of the horseshoe. So remember, when we translate arguments from English into our symbolic language, you have to supply the punctuation. The only way to know that you put it in the right place is to be able to read the symbolic statement back against the English. So I think probably, if not later on tonight, then a lot next week, we're going to practice reading that. But this is a good one for practice. They're fairly complicated statements. Anybody want to take a stab at? How about the third premise? Can you read the third premise for us?
The third one
Yeah.
is just B.
Yes! Excellent. How about the conclusion?
If if X then C.
Okay. You ready for the second premise?
Sure. If Z then A then if B then C.
Outstanding. How about that first premise? Are you ready? Sure?
Mhm. If both X and Y and Z then A.
Capital. Capital. You're going to have to be able to do that, or you're not going to get that portion of the test correct, or unless you're guessing, where you have to translate English. The symbolic language. Okay, let us begin our new procedure. We're assuming the argument form to be invalid. See this? Done. What do you think I should do next?
Put truth values on the other essences of B.
That's right, I need to transfer B's truth value. That's the only other occurrence of B. Now we look around for some symbol whose truth value we're certain of. I think we have to go to the conclusion again. Right? So I think you all know that the only way that horseshoe could be false is if the antecedent is true and the consequent is false. What do you think I should do now? Transfer the truth values to other occurrences of X and C. There's an X. There's a C. And that's about it. Now we continue the search, looking for a symbol whose truth value we know at this time. There's a real
The if B then C is false.
What is? The horseshoe? This horseshoe? It is. Now that opens up something in that same premise. Can I find it? Yes, go.
Means the first horseshoe. Oh, actually, hold on. Yeah, it means the first horseshoe has to be false.
Yes, why?
Because the only time that the
Tell me
middle
about these.
horseshoe can be true and with the antecedent consequent being false is if the antecedent is true.
Well played. False, right?
Sorry,
Okay.
I said.
Well, that opens up yet more assignments in that same premise. Find it, or them. Let me know what it is and why.
The antecedent of the first horseshoe has to be true, followed by the consequent being false, because it's the only time the horseshoe could be false.
Outstanding. Done. What do you think I should do now?
Transfer values. Right.
Truth values for Z and A.
Yes.
That C has to be true. That A has to be false. Now, that tells us something about the truth value in the first premise. Be careful about which symbol it is. We have a situation that's come up 5 or 6 times now, trying to keep this horseshoe true. Consequent is known to be false. Therefore,
everything within the brackets has to be false, and I think it's the and next to the Z.
the antecedent has to be false, and it is this dot, right? Well, that opens up yet something else in the first premise. Trying to make a false dot, right-hand conjunct is known to be true. So that left-hand conjunct had better be false. And what is the left-hand conjunct of this dot? It's this dot, right? And we have one symbol remaining. I'm trying to preserve now a false dot, the left-hand conjunct of which is known to be true. So that right-hand conjunct had better be
False.
boom. See, does everything add up? That's good. That's good. That's good. Good. Okay, so we succeeded. Bad news for the argument form, right? Because we've succeeded in justifying our assumption that it's invalid. So it is invalid. And that row, at least that row, exists on the very long truth table. Right? Catching on? Okay, there are a couple more glitches to encounter. Doesn't always go this smoothly. Nothing major though. And there are specific procedures to follow for resolving the issues. So let's continue, unless you have a question about that one. No, it's too late now. It's gone. Oh, these are getting long in a hurry. They're all very similar to each other. But let's see if we encounter something new here. Very similar looking argument form. Not exactly the same. Let's see, maybe someone can read that first premise for us. Very similar to the first premise of the last argument, with the exception of that right there. And the letters, of course. Anybody want to give that a read?
I'll try.
Okay, good. I'll point to the symbols when you need to say something.
If both,
No.
if both,
We're going to start over again. See, that was a dot before, and now it's a wedge. So we don't, when a wedge is in punctuation, we don't say both. You just read it like a plain old wedge, either this or that. Ready?
okay, let me try again. If both or
Either.
either D or E and
Oh,
if and F, if
then,
then G.
yeah. I screwed that up for you. Sorry. If both either D or E and F, then G. Sorry about that. That's my fault. Okay. Let's begin. Look, done. That premise is gone, right? Now what? You tell me. H? H's truth value? Okay. Now we're hunting around for some truth value we're certain of. See, we're going to the conclusion again. That's the only place to continue. I think you know what to do, right? In the conclusion? Right? Transfer D, true. I, false. Here, I want to point out something that is a legitimate step, but we want to save it for last resorts. There's a couple sort of last resorts. I know what that wedge is right now, and I don't care what E is. What is that wedge right now? It's true because one of the disjuncts is true, right? I could put true for that wedge